Okay guys, today we're going to do 10.6 exponential functions and base E. So I don't want to get overly involved with the number E. We'll just break it down as simply as possible because it takes calculus to fully understand the number E. But basically little a, the number E is a number that occurs in nature a lot, and E is approximately 2.7182, and we'll just say dot dot dot. It's a number that's used a lot in different areas of math and physics. We use it in this equation: V equals a e to the negative t divided by RC. That's for resistance across a capacitor, voltage across a resistor, not capacitor. And then little c, we use it in biology. Population can be described by initial population times E raised to some KT. And this is what we're going to be using here a lot in this class. All right, so little 2 or big 2 will say new exponential format. And we'll do like this. Let's see, let's say before and now, and we'll see how everything compares. So before we had the equation, how did I want to write it? We had Q equals A times B to the T, where A was the initial value and B was the growth factor. And we had R, which was equal to B minus 1, was the growth rate. Okay, well now we have something a little different. Now we're going to have Q equals A times E to the K to the T. And this is going to be for continuous growth. All right, so if that's for continuous growth, we'll still have A as the initial value. E to the K will be the growth factor. And K is going to be called the continuous growth rate. And K is the continuous growth rate. So a couple other things that we talked about before that we need to know now. When we had B between 0 and 1, that said that we had a exponentially decaying function. So now that means if e to the k is between 0 and 1, we'll have decay. All right, well, e is 2.718, so e to what number what number would I need to raise e by to get a number between 0 and 1? Well, that's simple. That means k needs to be negative. So if k is negative, we'll have exponential decay. And on the other side, when we had b bigger than 1, we had growth. So translating properly, that means e to the k would need to be bigger than 1 to get growth. And here k would need to be positive for that to happen. So when the continuous growth rate is positive, we have growth. When the continuous growth rate is negative, we have decay. Okay, so now let's go ahead and jump into some problems within the section. So big 2, some examples. Or big 3, I'm sorry, big 3 examples. All right, little a, let's do number 2 out of the book. So in number 2, we're told V equals 3500 e to the 0.173 t. And for number 2, we're asked to give the initial value, the continuous growth rate, the annual growth factor, and the annual growth rate. Well, first, the initial value is simple. That's just 3500. So initial value is equal to 3,500. And all this is an investment in dollars, so we'll put the dollar sign. All right, then we want the continuous growth rate. All right, well, the continuous growth rate is simply the coefficient in the exponent. So that's going to be 0.173 or 17.3%. All right, then number 3, we're then asked for the annual growth factor. All right, well, the annual growth factor is going to be the e raised to the coefficient part. So that's e to the 0.173. And we plug that in our calculator. And we get 1.1889. We'll round to 4 decimal places. So there's the annual growth factor. And then we're asked for the annual growth rate. And remember, that's going to be the b minus 1. So that's 1.1889 minus 1, which is 0.1889, which is 18.89%. Okay, so that's what they want for number 2 in the book. All right, so now let's look at number 7. So it'll be number 7 out of the text. Here you're given a function, q equals 20 times e to the negative t divided by 5. All right, so what we want to realize here is, let's rewrite this. We don't like it like this. So what we need to remember is, off in the scratch paper, if I have negative t divided by 5, I can write that as negative 1/5 times t. Okay, that's important because we always want to write this stuff as a number times the t. Okay, so that's what we're going to do here. So we're going to have q equals 20 times e to the negative 1/5, then to the t. That way I can see my growth factor and my continuous growth rate very clearly, because now we know little a, well, let's call it the initial value, is going to be 20, and the continuous growth rate remember, that's the little letter k. That's going to be equal to negative 1/5. And if you plug that in your calculator, that's minus 0.2 or minus 20%. Continuous growth. All right, and that's really all they want. Now, if we look at something like number 11, pull this up. They give you one pretty complicated. They give you q equals e raised to the pi times e to the 2t, all divided by e to the 7t. Okay? So what we need to do here is we need to rearrange it. This is going to be e to the pi times e to the 2t divided by e to the 7t. So I'm arranging it this way to put our variable factors together. And then if we use our rules of exponents, we get e to the pi times e to the 2t minus 7t, which is e to the pi times e to the minus 5t. So we can see here that our initial value is e to the pi, and whatever that number is. And if you're really curious, you can plug that in your calculator. Let's see, e raised to the pi, that is 23.1407. And then our, what do we want? Our continuous growth rate is negative 5. So that translates into a negative 500%. Okay, so that sucker's decreasing very quickly. All right, what about, let's try to do number 14 real quick. So little d, number 14. 14. It says a population is initially 15,000, so that tells me A is 15,000, and grows at a continuous rate of 2%. So we're told continuous rate is 2%. So this tells me that the number K is 0.02 as a decimal. Okay, so that's important. 2% is the number 0.02. And it says find the population after 20 years. Okay, well, first we need an equation. So let's see, P of t, we're looking for things in the form A times e to the kt because the word continuous was used. So we know A is 15,000 and that our K is 0.02. So here's our equation. All right, but the question is, find the population after 20 years. So that means I want to find P of 20. So that's going to be 15,000 times e raised to the 0.02 times 20. And we just plug this in our calculator, and be careful how you do it. So let me clear that. So this is, oh, don't want to cover that up too much, 15,000 times e. If you have one of these newer calculators, it makes it a little easier. 0.02 times 20. And what do we get? We get all that. So put that over here. So this is going to be 22,377. And how many decimal places should we round to? 0.37. And what we can do is we can round to whole to get 22,377 is the population, so people. All right, and finally, we'll do number 23. It says rewrite 5e raised to the 2 plus 3t in the form a times e to the kt. All right, so this is just going to take us back to our rules of exponents. Y'all will never get out of chapter 6, will y'all? So this is going to be 5e squared e to the 3t, right? Because this is a product of powers we would add, right? So we do it opposite. And then we put the constant terms together and leave the variable term by itself. So this is going to be, so 5 times e squared. That's going to give us our initial value, e to the 3t. So then we just put in our calculator 5 times e squared, and we get 36.9453 times e to the 3t. So A equals 5e squared, which is approximately 36.9453, and our k value is 3. Easy enough. All right, and you also have a worksheet to do tonight, so don't forget how to do the exponential regression, quadratic regression, and linear regression in the calculator, and I will see you guys tomorrow.